off maybe. Well done, Mark. So depending on where they're situated in buildings or what classifications of buildings, they can start different things up like smoke, like building management systems like air conditioning shutdown and such like. They can automatically close fire doors if they're linked to a panel. Remember I showed you some self-closing devices on fire doors last week, the electromagnetic locks. They can start extraction and pressurization systems up, which we go into later on. They raise the alarm, obviously, via the fire indicator panel, and via the fire indicator panel, they can call the fire service automatically. So these detectors can do quite a few bits and pieces, so they're very important in buildings, an early means of raising the alarm. So the first one we look at, you've got a photoelectric detector. Basically, it's a beam of light which hits a mirror constantly, and if you get smoke in that beam of light, it scatters all over the place, and through its electronic gadgetry, it then automates, then generates an alarm. Now, depending on the setting in there, it can actually go into a phase called pre-alarm, and that's not an alert tone. It can go through a pre-alarm phase, maybe for 5 minutes, 10 minutes, 30 minutes, depends how it's set, 30 seconds, depends how it's set up. If you get over the top smoke particles, if you like, within that chamber, that light scattering, it will then automatically set the alarm off in the building, depending on what building it is, whether it sets the alarm off the evacuation tone or goes into an alert tone, and then you wardens just respond to that. It can pick up smoke particles of typically around about 0.1 of a micron in diameter, which is that typical of a smouldering type of fire. So remember when we said about smouldering fires, they smoke, they produce huge quantities of smoke. You got things like fire retardants in carpets and chairs and things like that, which causes that smoke. And those smoke particles then go into those smoke detectors. So they're good for things like your furniture, your lounge rooms, your bedrooms. And then you've got the ionization type of detector. Again, this one's more electronic. It's got two chambers. One's open and one's closed, and it just lets the smoke into that chamber, and through a series of electronic gadgetry, it then sets the alarm off. Now, these are good for faster burning fires. And if you remember, faster burning fires, they're normally visible flaming combustion where the smoke is getting burnt off, and the smoke particles are very small, typically of around about 0.1 of a micron in diameter, which is naked to the human eye. So they're good things for your kitchens and what have you. So if you've got your chip pan on fire or something like that, you can get photoelectric and ionization detectors combined into one. Oh, where am I here? Here we go. So if you notice smoke detectors, when you go through buildings, they'll have a pole, and that light is going flashing every so often, every couple of seconds. And that means it's polling down to the FIP to say it's all serviceable. It could be a green light, could be a red light. If the detector's gone off, you will see a red light which is glowing constantly. So that's good for if your warden's inside buildings and you need to investigate the alert tone's gone off on your floor. Say if you're on level 5, you can look along the ceilings, and if you see a light in the detector, you know it's that one which has gone off. Obviously, if you see no visible flames or no fire or anything going off, you can probably assume that it is an unwanted alarm, and in which case you would get on the phone to the chief warden. But of course, if you're in doubt, you just evacuate anyway. You all with me still? No questions? Good. You can see these detectors as well can be put in loft spaces, under floorboards for loft. Now, obviously, if a detector goes off, you need to need to see the light on, see where it's gone off, especially in a type of building which it hasn't got a addressable system in it. Might have an old analog system where you could have 5 or 6 detectors or even 10 detectors connected to one loop. In fact, I think you can do up to 40 in one loop. So you need to know which detector's gone off. So for something like a boarding house, which we do procedures for, outside room doors, you've got the fire alarm, you've got this thing here, which is outside the door. And if there's a detector gone off in the inside, it will show outside that it's inside that room. And of course, then the wardens, the chief warden can put their emergency procedures in place of whatever they're going to do about that type of alarm going off. And obviously inside roof spaces as well, you can't see inside roof spaces, so you'll have one of these things here outside it. So it's a visible indication what detector's gone off. Okay, I must stress at this point, you guys, wardens and things, it's not up to you to crawl inside the roof space to have a look at that detector. It's your job to tell the fire service and let them know where it is. It's up to them to go into the roof space and have a look, see what's going on. These are beam tight smoke detectors. Again, very similar to the others. They've got a beam which goes from one side of the room to the other. They're good for high spaces. They're good for large open spaces. Do near enough the same as your photoelectric and that. Smoke interferes into a light beam. The light beam scatters all over the place. The electronics can't handle it. And again, sends the signal down to a fire indicator panel, starting all those good bits up, raising alarm, calling the fire service and things like that.
Yeah, good point, Nick. I mostly find those in refurbished heritage protected buildings where they cannot put a ceiling in sufficient to hold the normal detectors, and you'll find a lot of beam ones.
Nathan will probably be able to resonate on those ones as well, won't you, Nathan? Is he still there? Is he gone?
I could, but you've done a good job. So
okay,
I could talk techie, but I think just keep going, Nick.
Thanks, Nathan. So look, these are other type of smoke detectors, very early smoke detection apparatus, Bethesda, which you've probably heard about. Girls, Taylor and Bethany, you'll be hearing about these probably. And they can be linked to gas suppression systems. The other detectors can be linked to gas suppression systems, but the thing is you don't have so much of an investigation time to sort out, okay? So you could have two normal photoelectric smoke detectors. If one picks up smoke and then another one picks up smoke, it will release gas into a room to put out a fire in something like a computer server room, for example. But these ones here, these Vestas, they constantly sample the air, okay? Constantly sample the air. And you can put, what you can do with these Vestas systems is put the detectors on a wall at ground level, and then you can have pipes going off the detectors going into computer rooms or going up to high ceiling levels. And I think you can do up to around about 40 meters. They're very sensitive. So what you've got 4 stages of alarm. So you've got an alert stage, okay, which gives an occupant a warning. So you could be in a computer room, see a yellow light flashing, and you go, my God, what's happened? It gives you 30 seconds or so to get out of that computer room, because otherwise it's going to release the gas. And the gas kills fires, it kills people as well. All right. And I'll talk a bit more about that in a minute. But that doesn't actually set the alarm off in the building. It just alerts the occupants that something's going on so they can do some kind of investigation. The next action alarm will unlock one stage of the gas suppression system. Okay, so it's gone from one stage, you can see the lights here on this one. Sorry, see the lights here. Goes from one stage up to another stage. You can still go into the investigation stage, still hasn't called the emergency services. All right, set the alarm off in the building. If it detects more smoke, it goes into fire 1. All right, so it goes further up a level. Well, that's it. That's called the emergency services. It's put the alarm in the building, it started all the BMS, shut the fire doors, all that type of thing. If it then goes further into fire 2, it will then release gas into that room, killing the fire. Okay, so you're with me? So there's 4 stages of alarm. You've got alert, action, fire 1, fire 2. It's only when it actually gets to, you've got the alert and action, which gives occupants in that building or in that server room to be able to do something about it. And you can see here, this is one which has gone into fire 2 mode. And you can see the pipes coming off it. And this is typical for a server room. You could have 3 or 4 Vestas there separately, or you could have them all banked together. Now, when I said about the suppression system in there. Normally linked to them are these type of things here. All right, you can see that, can't you? So you've got an agent release button. You've got different manual call points in buildings, which I'll talk about in another session. But this one's a yellow one. Okay. If you've got a fire in there and nothing's gone off, visitor hasn't picked it up, you can come flying outside that room. You can lift up the panel and you can push the button. It's going to release gas into that room automatically. If you've got an alert go off in that room and it's giving you 30 seconds, 45 seconds, depending what it's set up for, to get out of that room and to investigate, and you find that there isn't a fire, you've got this button here. You can list a flat, you can push that yellow button, it will light up, and that will inhibit the alarm system. That normally happens if you get workmen going in there and if they haven't isolated the detectors. So you can inhibit the gas system to stop it going off. Gas, the reason everyone wants to do that, one thing, gas is very expensive. Two, it's very harmful for the atmosphere in most cases. Okay, so common types of gases, you've got these types here: argonite, intergen, halon, FM2000. FM200 is quite a common one, actually. Now, some of these gases you see are harmful to humans. Some reduce the oxygen levels to kill the fire to below 15%, but if they get below 12%, it becomes untenable for human beings. Okay, hence the reason you've got to get out of that room or sort it out. And you can see here, these are the type of signs you will get outside one of those rooms. So if it's gone into fire alarm, it say do not enter. And then if you've pushed that extinguishing system inoperative, it shows the people that the extinguishing system is inoperative. Did you all get that, guys? They're quite complex, Vesta, but they've got 4 stages. And obviously it's 2 stages, which gives you time to be able to investigate, to prevent, 1, the building going into evacuation, and 2, releasing toxic gas into the atmosphere or into these rooms. And you can imagine somewhere like Telstra, they have whole floors of these computer systems, and they don't want to release gas into them if they can help it, of course. So the benefits of Vesta, okay, so you can relate, they're easy to maintain. As I said, they're good for computer rooms, clean rooms, large open spaces, underfloorings, in ceilings, in prison cells. Put them right up high, 30 meters high, and you haven't got to get up there to maintain them. If you've got detectors at that height, you've got to get things like cherry pickers and what have you to be able to maintain them every year or so, I think it is. Whereas these Vestas, the detectors are on the ground floor, and you've just got the pipes going up to the ceiling level. Photoelectric and ionisation detectors both have their advantages, but like I say, photoelectric can detect smoke very quickly. Okay, so detect smoke in the smouldering stages of a fire. You imagine a high-rise building where you've got an alert tone for a couple of minutes and then it goes into a vac. Well, the photoelectric detector, it picks up a fire in the early stages. So that gives you more time, and it gives you guys time to be able to get everyone out through the emergency exit. The ionisation type of fire is good for your kitchens and things like that, where you've got maybe faster burning fires. Oh, look, these detectors are very good at picking up smoke, but your nose is even better than these detectors. So if you're on a floor on a normal day in your office, you sometimes go, can I smell burning? You go and investigate. Good thing about humans, they're the best detection and suppression system on the planet, because you can smell smoke, you can go to it and say it's electrical fire, I need a CO2 extinguisher. A smoke detector can detect smoke and say that's a fire, but they can't tell you what type, so they can't tell you what extinguisher to select. This is one smoke detector here. Here's a Vesta system which is protecting an atrium in a building. This goes up actually, I think, 13 floors. So if there was a fire on the ground floor, it would work like a chimney. Okay, and that's a fire wire there. And that fire wire, I think it's 25 degrees or something, I can't remember, but it breaks the link. And if then Vesta picks up smoke as well, what it does, those 2 inputs into the panel actually set sprinklers off on the ground floor. If Vesda then picks up on the top floor here, right at the top, it will start 5 extraction systems up on that, into that area, which literally, because there's all these offices are open space, and I've seen them go off in that building, they literally pick people's papers up off the desk. So the extraction systems go on, louvers open up in the windows to let the air in, and it literally sucks all that air through that chimney and out through the top of the building for a matter of life safety. These detectors here, wouldn't you believe, I got these on a fire order I did, and that was in a hotel in Adelaide. So you can see they actually need some kind of maintenance conducting on them. So if you want to know a bit more about smoke detectors, there's some layman's terms there, and you'll be able to get this. I'll send you this presentation later on, and you'll be able to go to that link and you'll be able to see on YouTube how these detectors work. And if there's nothing else, have you got any questions, guys?
Yeah, I have, Nick.
Go on then.
Tell me very simply, in your eloquent way, how I can walk into a building, look up and go, that is a smoke or that is a thermal, where I cannot stand up and look horizontally through to see the little
Right, the only other way you can do it is if you've got knowledge of them, right? Or if you can see the little probe sticking down, which on those type of guys. But the other way you can do it is go to a block plan, yeah. And obviously, if it's a both detectors, it should show you on the block plan whether it's a thermal or it's a smoke detector. Because sometimes I have to go to look on block plans.
Yeah, I've looked at many, and they appear to be a thermal or a smoke detector. You open it up, and which I have done on a few, disassembled them, and it's a thermal. Or it's a smoke detector with one of those coloured dots. Now, I know that's getting a bit technical.
Yeah.
And if it's got a coloured dot, like why do smoke detectors have a black dot put on them?
Sometimes they have T put on them as well for thermal.
Okay, all right.
Yeah, but
and on the
people want to tell you.
Yep, that's a good point, Nick. Thank you. And the Vesda systems, not only are they, as you correctly point out, they're for a tall space. As Chadstone Shopping Centre is riddled with them. They're not the normal aspirating tubes that I call them, or the conduit pipes with holes in them. I don't know what the technical term is. I can only describe the sensors as like a flower, like a tulip.
Nathan might be able to tell you. Nathan, are you still there?
Yeah, no, they're air sampling detectors, which are sometimes they're just smoke detectors in an enclosure with some tubes hanging out of it.
Yeah, these ones at our big shopping centre, Chadstone, are right up in. Obviously, it's an alternate solution near very large atrium and glass dome roof. All around that are the little sensors that I call the tulip. They look like a tulip flower. They're very small with like a curved lip end, usually a white colour with a bit of a red band around them.
Take a photograph, Mark.
Yep.
And send it to us.
Okay.
All right. Was there anything else, anyone? Any comments?
Not from me, Nick.
Was I technically right there, Nathan?
Yeah, no, I think so. Yeah, I mean, it is hard to distinguish between the different sorts of detectors. You really have to sort of know the models of detectors. And there aren't actually that many in Australia. So once the more experience you have looking at them, the more easy it is to pick them up. Also, the other thing about, you said look at the block plans, Nick.
Yeah.
That places like South Australia have at the fire indicator panels, they actually have the block plans, which will show the detector types and their addresses of those detectors. So as an example, important aspects of these detectors is having an identifier on the detector, which correlates to the block plan as well, because you need to know that if it's detector loop 1, sensor 1, that is in the right location as per the block plan, because if the fire brigade or if a responder is going to try and investigate that location, that needs to be correct. So that's something else. If you're doing an audit of a building, often make sure that the zones or the device identifiers on the block plans actually match what you're looking at. And color coding is another thing I've seen as well. You talked about a black dot or a green dot or whatever else. Sometimes they can be color coded. There's all sorts of stuff that I've seen across different states. Anyway, there's just a couple of comments there on that one.
Thanks, Nathan. Thanks. So what I'll do, guys, if you stop recording, Mark, I will get this. I'll load it on. I'll put it onto YouTube as well. I'll send you all